Cluster analysis. Let me introduce what the term cluster means. Cluster is a group of similar things or a group of things which are closer together. So we can see that cluster analysis is a statistical method used to group similar objects in a cluster. Now, hierarchical clustering method is a part of a cluster analysis. It is one of the classification of cluster analysis. And this method is used to group data into a tree of clusters. Again, it is classified into two methods. First is agglomerative and the second one is divisive method. Agglomerative method, it starts with each item being in its own cluster, then the clusters are merged. Hence, the minimum point required to make a cluster is 1. It is also known as bottom-up approach. Divisive method is clusters are split into two separate clusters and so on for every successive clusters until each item is in its own cluster. Hence, it is known as top-down approach. Again, we can say that in agglomerative method, like if there are 2 or 3 points, then each individual point will form a cluster like this, and after then these two were merged, and then these two and the all three in one cluster. Now in divisive method, if there are 4 or 3 points in a cluster, then it will divide into two cluster, like 2 points in one and again 2 points in another cluster, and so on it will move on. Here we will use agglomerative method, and because it is widely used rather than divisive method. The reason is here, like agglomerative method is mostly used rather than divisive method, because they produce a series of partitions of data, the first consisting of small m single member clusters, the last consists of single group small n individual. This method is basically based upon proximity matrix method. Or also we can say that in agglomerative method we start by computing distance among m objects. Hence there are less calculations and each step up requires fewer calculations, as it is, that's why it is known as bottom up approach. But in divisive method we use more calculations, like as the name suggests, top down approach. So we will divide each time we need to divide the cluster into two other parts and again two other parts. Hence agglomerative method is widely used. Now agglomerative method is divided into two types. Single linkage method, here we will use equidistant formula, like distance for 2 points is equals to x2 minus x1 का whole square plus y2 minus y1 का whole square, like this. And the another one is centroid linkage method. Now let's look into this problem. Okay, the question is, use single linkage method to form a cluster from the given table. Show the clustering in figure and draw the dendrogram. Here we will see how we will use single linkage method to calculate the points. Calculate the points and to form a single cluster with these points. Now at first we have to make a adjacency distance matrix from this given points. How we will make that? Let's see. P1, P2, P3, P4, P1, P2, P3, P4. Now just look into the points given, like P1 to P1 0, P2 to P2 0, and P3 to P3 is 0. As we will know that P3 to P3 is a single point, so hence it will be 0 only, and P4 to P4 is 0. Now how we will calculate P1 to P2? See here, we simply use the distance formula for calculating the value. Like here P1, the points at P1 is 1 and 3, points at P2 is 0 and 2. So 1 minus 0 square plus 3 minus 2 square. That is 1 plus 1, which is root 2. Here it will be root 2. Similarly, P1 to P3. I'm not writing here as P2 to P2 is like P1 to P2. It will be again P2 only. Similarly, we know about the lower triangular matrix and the upper triangular matrix, so I'm using that. The value of both will be same, hence I'm simply writing the lower triangular matrix. This. Now for P1 to P3, again P1 P3 will be like P1 to P3, 1 and 2, 3 and 5. That is 1 square plus 2 square, which will be 5, root 5. Right. Similarly, we will do for P1 P4. Again P1 P4 will be P1 P4, 4 minus 1, 3, 3 square plus 3 minus 1, 2 square, which will be 9 plus 4, that is root 13. Similarly, P3 and P2, P2 P3, that is 0, 2, 2, 5. P2 P3, 0, 2, that is 2 square plus 2 minus 5, that is minus 3 square, that is 3 square. Again it will be root 13, so here it will be root 13. Now P2 to P4, P2 to P4, 4, 0 minus 4, 4 square plus 2 minus 1, 1 square. 4 square plus 1 square, that is 4 plus 16. 4 square 16 plus 1, that is root 17. Again P3 to P4, P3 to P4, 2 minus 4, that is 2 square plus 5 minus 1, that is 4 square. That is 4 square plus 2 square. 16 plus 4, 20, that is root 20. Now let D1 be the initial adjacency distance matrix. I just wrote the above matrix into this. I just give the value of root. I just write the value of root 2, root 5 and nothing else. Now our first step is to check for the least non-zero value in this matrix. So here we can say that 1.4 is the least non-zero value in this matrix, and 1.4 comes in which cell? In P1 and P2. Comes in P1 P2 cell. Hence it is the least distance. Hence since it is the least distance, so we will since 1.4 comes in P1 P2 cell and it is the least distance, so we will form a cluster using these points, a single cluster with these points. Like here is the diagram. If it is P1, it is P2, P1 P2. I'm writing for P1 P4. So P1 P2 is the least value, hence we will form a cluster with these 2 points. Now P1 P2 is in a single cluster. Now our step 2 is to calculate the distances. Let's see how we will calculate. Now we will calculate the distances of the other points with this single cluster, like D of 1 to 2 with 3, the single cluster with 3, distances of this with this one with 3. How we will calculate? Using this minimum of D. D is the distance of 1 to 3 and D of 2 to 3. Okay, right? Like now the value of this we will get from this initial adjacency matrix. Minimum of, we will take the minimum value of both these points. Now D1 distance of 1 to 3 is 1 to 3 means P1 to P3 is 2.2. So 2.2, and 2 to 3, that is P2 to 3 is 3.6. So the minimum of this two value is 2.2. Right? Similarly, we will calculate for the another point, that is 1 to 2 with 4. 1 to 2, 4. Minimum of D 1 to 4 and D of 2 to 4. Again, from this matrix, we can say that D of 1 4 is P1 to P4 is 3.6, comma 2 to 4, P2 to 4 is 4.1, and the minimum value is 3.6. So the value of this is this, and this one is 2.2. Right? Now we will now our the initial adjacency matrix, distance matrix will change as we just form a cluster with these 2 points, hence it will change. Like let's say the matrix is D2 and the points will be like P1 to P3, P4, here P1 to P3 and P4. P1 to is 0, P3 to P3 is 0, P4 to P4 is 0. Now from here we can say that P1 to 3, here we have calculated the value is 2.2. P1 to 4, the value is 3.6, and it will be as it is, like P2 to P4, P3 to P4 is 4.5, so 4.5 here, and just wrote it. Now our step 3 is to check for the lowest non-zero value from this matrix, from this D2. So here we can say 2.2 is the lowest distance or the lowest value, non-zero value, and 2.2 comes in the cell of P1 to 3. So we will cluster the points 1, 1, 2 with 3. Now it will be in a single cluster. Now 1, 2, 3 will be in a single cluster like this. 1, 2, 3, 4. 1, 2, 3, 4. At first it was in a single cluster, and then the points 1, 2, 3 will be in a single cluster. Similarly, as we have done in step 2, we will calculate the distance of this cluster with this point, that is D1 to 3. It will be as it is in a single cluster, so with 4 we can say we can calculate it as minimum of D1 to 4, D2 to 4, and D3 to 4. From here we can say that D1 to 4, P1 to P4 is 3.6, 2 to 4 is 4.1, and 3 to 4 is 4.5. So the values will be like minimum of 3.6, 4.1, 4.5, and minimum of this is 3.6. Now we will again make the matrix, which is as follows. Let's say D3 be the matrix. So 1, 2, 3 was in a single cluster and 4 was remaining. So P1, 2, 3 in a single cluster, P4, and here similarly P1, 2, 3 and P4. P1, 2, 3, P1, 2, 3 is 0, and P4 to P4 is 0. Now the only thing is remaining P1, 2, 3 with 4. So we have calculated it was 3.6. Now the points 1, 2, 3, 4 all will be in a single cluster, which is as follows. 1, 2, 3, 4. 1, 2, 3, 4. And now the whole in a single cluster, right? Now we don't have to go further. Here we will stop our calculation. Let's draw the dendrogram. We had 4 points now, so 0, 1, 2, 3 and 4, 1, 2, 3 and 4. Our first cluster was at 1 and 2, was with 1 and 2, and the distance was 2.2. No, it was 1.4, which will lie around here. So making a bar over here. Again, our next cluster will was with 3, 1, 2 with 3, right? And the minimum value was 2.2. Yes, 2.2 was the minimum value. So it will be around here, like this, and we will just make right. And our next cluster, a single cluster, was with 1, 2, 3 and then 4, and the minimum distance was 3.6. Yes, 3.6, which will be around there. So we will draw. So this is our dendrogram. Thank you.